Okay, so this is the 2024 Ordinary Level Maths Paper 2, Question 1. The scores for 9 students in a history test are given in the table below. X is the lowest score and Y is the highest score, where X and Y are natural numbers. Write the scores in order from the lowest to the highest in the spaces below. Okay, so we have X and Y already done, so when you go through all of these you'll find that 37 is next, then 42, then 54, then 74, then 76, 82, and 91. Okay, so that's part 1. Let's have a look at part 2. Find the median of these scores and explain what this score means in the context of the question. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 numbers. Divide by 2 is 4.5, round that up to 5, and it's the fifth number, 1, 2, 3, 4, 5, so it's going to be 74. Okay, so what does it actually mean? So it means that 50% of students scores are lower than 74 when the scores are in order So 50% of the students' scores are lower than 74 when the scores are in order from lowest to highest. That's the median. All students receive different scores in the test. The range of these scores is 61. Work out the maximum possible value for X and the corresponding value for Y. So if we look at these scores, we've got to work out what X and Y are. We're told that the range is 61. We've got to work out the maximum possible value for X. So the maximum possible value that X could be then would have to be 36, one lower than 37. We're told that all the scores are different, so one lower than 37 would be 36. So let's work with that anyway. X is 36, and then Y then would have to be 36 plus 61, because we're told that the range is 61. So that would give you, let's see, 797 for Y. Okay, that's it. Let's have a look at the next one. A different group of 5 students did a maths question. Their scores were as follows, where T is natural. So we have 15, 16, 19, T, and 26. The mean of the 5 scores is 19.6. Work out the value of T. So to work out the mean, we've got to add all these up. So it's 15 plus 16 plus 19 plus T plus 26. We've got to divide it by 1, 2, 3, 4, 5 numbers. And we're told when we do this that the mean is 19.6. So when you add all of those up, you get 15 plus 16 plus 19 plus 26. That gives you 76 over 5. Next thing you would do is multiply across by 5 to get rid of that 5. That'll give us 98. And then finally, to find T, subtract 76 from both sides, and that will give you 22. So T in this case is going to be 22. That's it for the first question. Okay, so this is question 2. Sean is playing a game with 14 cards. 7 of the cards are green, numbered 1 to 7. The other 7 cards are red, also numbered 1 to 7. Complete the table below to show all possible outcomes when a card is chosen. Some have already been completed for you. For example, G2 means the card is green with the number 2. So you just got to fill these out. Let's see, we've got a green and a 1, green 2, green 3, green 4, green 5, green 6, and green 7. Same down here, red 1, red 2, red 3, red 4, red 5, red 6, and red 7. Okay, so that's part A completed. Let's have a look at part B. A card is chosen at random. Work out the probability of getting a card with an even number. So we want the probability of getting an even number. Well, there are 1, 2, 3, 4, 5, 6 even numbers. So 2, 4, and 6 green and 2, 4, and 6 red. So 6 numbers out of a total of 14. Simplify that, 3/7. Okay, that's that one. Next one. Sean picks a card at random and doesn't replace it. It is a red 5. He then picks a second card at random. What is the probability that the second card is a green card? So we want the probability the second card is green. Well, he's already picked a red 5. There are 7 green cards left, so it's going to be 7. But there are only 13 cards left in the pack, so it's out of 13. Because he's already picked a card and he hasn't replaced it, so there are only 13 cards left. That's that one. Sean picks a card at random and doesn't replace it. He then picks a second card at random. Find the probability that the second card is a different colour and a different number from the first card. So if we have a look at our table again, let's say he picks this one first and doesn't replace it. He then picks a second card at random. Find the probability the second card is a different colour and a different number. So a different colour would be here, and a different number means that there are only 6 left. 1, 3, 4, 5, 6, and 7. So really, whatever card he picks initially, there will only be 6 cards that are a different colour and a different number left. So it's going to be 6, and there are only going to be 13 cards left, so it's going to be 6 out of 13. So the question was, find the probability that the second card, it's going to be 6 out of 13. And that's it for question 2. Okay, so this is question 3. A line has equation y is equal to half x minus 1. Show that the point 4, 1 lies on L. Okay, so it's just take y is equal to a half x minus 1. Put in y, which is 1. Put in x, which is 4. And see, do they equal? So you got 1 is equal to a half. 4 is 2 minus 1. So 1 is equal to 1. Therefore, 4, 1 lies on L. Okay, so that's part 1. Let's have a look at part 2. Draw the line L on the coordinate diagram below in the domain -4 to 5. Okay, so what we need to do here, just look at our line. Our line equation, rather, is going to be y is equal to half x minus 1. So let's put in a few points. To draw a straight line, you don't need too many points. You need the first one, the last one, and maybe one in the middle. We already know that 4, 1 lies on the line, so we could maybe plot that anyway. So 4, 1 is here. Let's do a few more. Let's do x is equal to -4. So x equal to -4 would be y is equal to a half minus 4 minus 1. So that would give us a y value of half of -4 is -2. -2 minus 1 is -3. So for an x value of -4 we get -3. So -4 -3 is a point. That would go there. Let's have a look at another one. Let's have a look at 0. 0 is always a good one to do. Y is equal to a half of 0 minus 1. That would just give us y is equal to -1. But that's going to be here. Let's do one more. Let's do 5. So y is equal to a half of 5 minus 1. So y is equal to half of 5 is 2.5. 2.5 minus 1 is 1.5. Okay, so let's just draw that one and join these up. So we have 5 and 1.5. So 5 and 1.5 is going to be around here. So that's our line. So that's part 2. Let's have a look at part B. 4 lines are drawn on the coordinate diagram below, labelled A, B, C, D. Their slopes are given in the table below. Write A, B, C, D in the correct place in the table to match each line to its slope. Well, there's only one slope here with a negative, that's negative, so we can identify that one anyway. So let's do that. So the only negative sloped line is A. So that's going to be A there. Now there is one with a slope of 0, so that's going to be horizontal. The only horizontal one is B, so that's going to be here. That is a 0 slope. The other two are this one here and this one here. D has a bigger slope than C, so this one here is going to be D and this one here is going to be C. And that's it for this one. Let's have a look at part C then. Find the equation of the line through the point 0, 6. So we have 0, 6 and we have 2, 9. So to find the equation of a line we use y minus y1 is equal to m into x minus x1. Now in order to use this formula you need two things. You need a slope and you need a point. Well, we have a point. We have in fact 2 points to use. Either one will be fine. We don't have the slope, so we've got to find the slope, and we're going to use this formula here. So these formula are in your tables. So if I identify these as, let's say, x1, y1, x2, y2, just put them in. So it's y2 is 9, y1 is 6, x2 is 2, x1 is 0, 9 minus 6, 3 over 2. So that's our slope. So let's put in some values here. I'm going to use x1, y1. I'm going to use 0, 6 as my point. Y minus 6 is equal to 3 over 2 times x minus 0. That's the equation of our line. So let's just simplify it a little bit. So I'm going to take the 2 on the bottom of the fraction, 3 over 2. I'm going to take that 2 and bring it over to the other side. So I'm going to multiply, in other words, both sides by 2. That'll give me 2 times y minus 6. The 2 is gone, so I'm just left with 3 and the x minus 0. So multiply it out, you get 2y minus 12 is equal to 3x. And there's a couple of ways you can write this. I'm going to write it in the form ax plus by plus c equal to 0. So I'm going to bring everything over to one side. So it's 3x minus 2y plus 12. And that's it. That's the equation of our line. And that's it for question 3. Okay, so this is question 4. The circle K has equation x minus 5 to be squared, y plus 3 to be squared is equal to 25. Write down the center and the radius of the circle K. Okay, so the center is going to be this value here and this value here with the signs changed. So it's going to be 5 minus 3. The radius is going to be this value here square rooted, because that's r squared, so it's going to be the square root of 25, which is 5. Okay, use algebra to investigate if the point 9, 2 is inside, outside, or on the circle K. So what we got to do here is just write down our equation of our circle, which is x minus 5 to be squared plus y plus 3 to be squared is equal to 25. And we just put the x and y values in and see what happens. So if we put x in, we'll get 9 minus 5 to be squared. If we put y in, which is 2 plus 3 to be squared, is it equal to 25? Is it bigger than 25? Is it smaller than 25? Let's have a look. 9 minus 5 is 4. 4 squared, 16. 2 plus 3, 5. 5 squared, 25. So it's clearly not equal to 25. So what we'll get here is 41, which is actually bigger than 25. So it's not equal to it up along here. 41 is bigger than 25, therefore it lies outside. Outside K. So let's just tick that off. Is that all we had to do there? Use algebra to investigate if the point is inside or outside. Okay, a different circle has center 4, 1 and radius 3. Construct this circle on the coordinate diagram below. So 4 minus 1 is here. And you're going to have to use a compass, and it has radius 3, so you're going to have to go 1, 2, 3 units out along here and then draw a circle. So I'm not going to be able to draw this, but it should look generally something like this. Let's say 1, 2, 3. It's going to have to come out here, 1, 2, 3, up as far as here, 1, 2, 3, out as far as here, and 1, 2, 3, down as far as here. So the circle will, let's say, come around like this. Whoops. Anyway, you get the idea. That's not a very good circle, but it should look generally something like that. Okay, so let's look at part C. The point 2, 1 is the lowest point on the circle S with center C as shown in the diagram below. The y-axis is a tangent to the circle S. Work out the radius and the center of this circle S. So the radius is just going to be this distance across here, and we can see that if this is the lowest point down here, then the x value here for the center has to be 2, because the distance from here to here is 2. Now what about the y value? Well, the y value is going to be the distance from here to here. And what distance is that? Well, it's going to be 2 anyway. It's 2 from there to there. And we can see that it's going to be 1 from here to here. So the distance on the y-axis is going to be 3. The center is 2, 3, and the radius is 2. So the radius is 2 and the center is 2, 3. And that's it for this question. Okay, let's move on to the next question. Question 5. A large group of 17-year-olds were asked how many hours of sleep they got on the previous night. The results were normally distributed. The middle 68% slept between 7.2 and 8.4 hours, as shown in the diagram below. Use the empirical rule to answer parts A1 and A2. Fill in the 3 missing numbers on the horizontal axis. Okay, so we have 68% between 7.2 and 8.4. The empirical rule uses 3 numbers really. It's 68%, 95%, and 99.7%. They're the 3 numbers you've got to remember. So 68% you're looking at 1 standard deviation above and below the mean. 95% you're talking about 2 standard deviations above and below the mean, and 99.7% you're looking at 3 standard deviations above and below the mean. So we currently have 68%, so 7.2 must be 1 standard deviation below the mean, 8.4 must be 1 standard deviation above the mean. So we've got to work out the mean. So how do you do that? The mean is going to be 8.4 plus 7.2 divided by 2, and that will give you 7.8. So this number here must be 7.8. It's just halfway between these 2 numbers. So that's 1 standard deviation above, 1 standard deviation below, and the mean in the middle. So what is our standard deviation then? Well, the standard deviation is going to be the distance between here and here. So what we've got to do is take 8.4 and subtract 7.8, and that'll give you 0.6. So that distance there is 0.6. So what we've got to do is take 8.4 and add 0.6. That'll bring us up to 9.0. We've got to take 7.2 and we've got to subtract 0.6. That'll bring us down to 6.6. So there are 3 numbers. Let's have a look at the next one. Research says that 17-year-old should get at least 9 hours of sleep each night. What percentage of this sample got at least 9 hours of sleep on the previous night? Okay, so 9 hours, that's 2 standard deviations above and below the mean. So this is 2 standard deviations above and below the mean. So that's going to be 95%. 95% of the data is going to be between those 2 values there. So that leaves 5% outside those 2 lines, if you like. So that means this must be 2.5% down there, 2.5%, and this must be 2.5% on this side. So the question was how many got at least 9 hours sleep. So at least 9 hours sleep is going to be up in this direction here. So we're looking at 2.5%. So the answer there is, our answer is 2.5%. Okay, let's have a look at B. Owen records the number of hours of sleep that he gets each night for several weeks. Based on this, he calculates that he gets the recommended amount of sleep 10% of the time. What is the probability that he does not get the recommended amount of sleep? So the recommended amount of sleep, a little prime over it, or complement if you like, he doesn't get the amount of sleep that's recommended, is just going to be 1 minus 0.1, or 100% minus 10%. If you like, 100 minus 10 is 90%. and we're just looking at 1 and 0.1, which is the same thing, so we're looking at 0.9 or 90%. So the probability that he does not get the recommended amount of sleep is going to be 90% or 0.9. Beginning on Sunday night, Owen records his sleep each night for a week. Find the probability that Owen gets the recommended amount of sleep, so the probability that he gets the recommended amount of sleep for the first time on Tuesday night. So we're starting on Sunday night, so if we look at Sunday night, he doesn't get the recommended amount of sleep, so that's 0.9. Monday night, then, he doesn't get the recommended amount of sleep, so that's 0.9. So it's Sunday and Mondays. And when we use the word "and" in probability, generally we're looking at multiplying. So it's 0.9 times 0.9. And then on Tuesday, he does get the recommended amount of sleep, so that's multiplied by 0.1. So that's all we've got to do there. Just multiply those three probabilities, and you should get 0.081. That's it for this question. Okay, let's move on to the next question, question 6. The diagram below shows the triangle XYZ. Construct a bisector of the angle XYZ using only a compass and a straight edge. Show all your construction lines and arcs. Hence construct the incenter of the triangle XYZ below. Okay, so I'm not going to be able to do this, but I have done a video on this. If you want to have a look on my website or on the YouTube channel, you can find the constructions for an incenter and other constructions as well. But I'll just generally do this freehand, show you generally what needs to be done. You need to get your compass, put it, what angle do we need to bisect first? XYZ. So we need to bisect this angle down here first. So what you're going to do is you're going to put the compass here first. You're going to draw an arc here, let's say, and another arc here. You're then going to just identify those points there, or put a point there and a point there. You're going to then put your compass here, and what you're going to do then is draw another arc out here from there, and then you're going to put the compass here, and you're going to draw an arc out here, and you're going to join that up to that. You're going to do exactly the same then from, let's say, this side here, or this angle here. So you draw an arc here from Z, and then what you do is you put your compass on this, let's say this point here, draw an arc, and then put your compass here, draw another arc from there, join that up to Z. But this is your incenter here. This is your incenter here. So when you bisect 2 or 3 angles in a triangle, the intersection of the 3 bisectors, or the 2 bisectors, will be your incenter. So as I say, I have done a video on this, so you can have a look at that. It'll be a lot more accurate than this. Okay, so that was that part of the question. Let's have a look at the next one. So part B, the diagram below shows the triangles ABC and ADE, not to scale. The triangle ADE is the image of the triangle ABC under enlargement. Some of the lengths are shown on the diagram. Use the length BC and DE to show that the scale factor is 3.5. Okay, so we have this triangle here, which is enlarged by a scale factor of 3.5, and it gives you this big triangle here, ADE. So the scale factor is 3.5, so what that does is it scales up lengths by 3.5. So in other words, if you multiply 4 by 3.5, you should get 14. They want us to prove that, or show that, the scale factor is 3.5. So what you would do there is just take 14 divided by 4, and that does in fact give you 3.5, which is our scale factor. So this is the length DE divided by the length BC. Okay, so that's that one. Let's go again. Part 2. AC is 6 units, and we can see that AC here is 6 units. Use the scale factor to find the distance from C to E, that is the distance from C to E. So we want to find the distance from here to here. So what I'm going to do is I'm going to multiply 6 by the scale factor, and that'll give me the length of the corresponding side on the image triangle. So if I multiply 6 by 3.5, in other words, I should get the distance from here to here, from A to E. All I've got to do then is subtract 6 from that, and that'll give me CE. So let's multiply 6 by 3.5 anyway. So I'm going to take 6, I'm going to multiply that by 3.5, and that'll give us 21 units. So that's the distance from A to E, which is not what we want. We want the distance from C to E. So the distance from C to E then is just going to be the 21 units minus 6. So that'll give us 15 units. That's all you've got to do there. Okay, let's have a look at the last part then. The area of triangle ABC is 11 units squared. Find the area of the triangle ADE. So we're given ABC. We're told that this here is 11 units squared. We've got to work out the area of the image triangle AED. So what you've got to remember is if the scale factor is 3.5, that will increase the lengths by 3.5. You multiply 4, for example, by 3.5 to give you 14. But in terms of area, if you want to find the area of the triangle ADE, the image triangle, you've got to multiply 11 by 3.5 squared. So what we've got to do is take 11, we've got to multiply it by 3.5 squared. If you do that, you'll get 134.75 units squared, and that's equal to the area of triangle ADE. Okay, so that's it for this question. Okay, so let's move on to the next question. Question 7, the first of the long questions. A company was interested in investigating the fitness of its employees. The table below shows the heart rates of 10 employees measured before and after exercise. Their heart rates are measured in beats per minute. So that's the table there. Complete the back-to-back stem and leaf plot below to show this information. 2 values are already filled in. Okay, so we've got to fill in this stem and leaf plot. Now you've got to make sure that you put these in order. So we have 60, we have 65, we have 67 and 68. Underneath that you've got 70, 76 and 77. And then let's see, we have 83, 88 and 89, and then on the right hand side we've got 71, 79, 81, 83, 87, 91, 102, 108, 113 and 118. So that's the stem and leaf plot filled in. Let's have a look at the questions here. The values for the heart rates after exercise are shown again below. Work out the mean and standard deviation of the heart rate after exercise. Give each answer correct to 1 decimal place. So there is a kind of a manual way of doing these, but it's probably best just to type the information into your calculator. Your calculator will do it for you. So you should find when you do that, the mean will be 93.3 beats per minute. The standard deviation from your calculator will be 15.1 beats per minute. Okay, based on your stem and leaf plot, how has the standard deviation changed following exercise? Give a reason for your answer. So if we look at the stem and leaf plot, we can see this is before exercise and this is after exercise. So you can see that the heart rates have increased after exercise, and also they seem to be a bit more spread out as well. So that would be our answer. Let's see, based on your stem and leaf plot, how has the standard deviation changed following exercise? So something along those lines. So the standard deviation has increased because the data are more spread out after exercise. Okay, so that'll do for that one, I think. Let's have a look at the next one. A scatter plot of the data is shown in the diagram below. So we have heart rate before exercise on the x-axis, heart rate after exercise on the y-axis. Or is a correlation coefficient between the heart rate before exercise and the heart rate after exercise. Based on the diagram above, pick the value from the list below that is closest to or. Give a reason for your answer. So we're given four values here, minus 0.8, minus 0.2, plus 0.3 and plus 0.9. We can see that if you were to draw a line up through the middle of this data here, that it is in the positive direction. So it can't be minus 0.8 or minus 0.2. So is it 0.3 or 0.9? Well, 0.3 would indicate a weak correlation and 0.9 would indicate a strong correlation. So we can see if you were to draw a line up through the middle of this data that the correlation is quite strong. So my answer is going to be 0.9. And the reason for that then I'm saying is there is a strong positive correlation between the heart rate before and the heart rate after exercise. And that would be the reason. Okay, so let's move on to the next one. Let's see, a random sample of 355 people was picked from everyone who took part in a park run in 2023 in Galway. Show that for this sample the margin of error for the population proportion is 5.3% correct to one decimal place. So the margin of error is given by 1 over square root of n, where n is the sample size. So in this case it's 1 over the square root of 355. So when you do that you'll get 0.05307 and so on. So as a percentage correct to one decimal place, this is equal to 5.3% to one decimal place. And that's it really. Okay, let's try the next one. 96 of the 355 runners finished the run in under 25 minutes. Work out the percentage of runners in this sample who finished the park run in under 25 minutes. Give your answer correct to the nearest percent. So what they're really asking you to do here is find 96 as a percentage of 355. So it's just 96 over 355, and then as a percentage you've got to multiply by 100. So when you do that you get to the nearest percent is 27%, and that's to the nearest percent. And this is actually called p hat. But you're not asked for that, you're just asked for this value here. Okay, so let's do the last bit here I think. A running club commentator said Galway Park Run times have changed since 2019. In 2019 it was reported that 24% of all runners finished the park run in under 25 minutes. Use your answers to part B1 and B2 to test the claim that the percentage of runners who finish the park run in under 25 minutes has changed since 2019 at a 5% level of significance. Show relevant calculations, state your conclusion and give a reason for your conclusion. Okay, so what we would say here is, this is an hypothesis test if you like, so your null hypothesis is that P, the population proportion of runners who finished the park run in under 25 minutes, is 24%. That's what it was in 2019, that's what they're saying here, 24%. So the alternative hypothesis then, which we call H1, is that P is now not 24%. Okay, so the calculations you would do then, you would say that the population proportion is greater than or equal to, less than or equal to the 27% minus the margin of error, which was 5.3, and 27% plus the margin of error, which is 5.3. So in other words, your population proportion is going to be somewhere between the p hat minus the margin of error and the p hat plus the margin of error. That's the formula we're using here really. So 27% we worked out as our p hat. We're going to subtract 5.3 and we're going to add 5.3. So our population proportion then is, when you take 5.3 from 27, you get 21.7%. And then when you add 5.3 to 27, you get 32.3%. So this is our confidence interval. So what's our conclusion then? Well, our null hypothesis was that the population proportion of runners who completed the park run in under 25 minutes is 24%. So 24% is between 21.7 and 32.3. It is within our confidence interval. So the conclusion then is we fail to reject the null hypothesis. And we would say something like, there is not enough evidence. There is not enough evidence to suggest that the percentage of runners who finished the park run in under 25 minutes has changed since 2019. The reason for the conclusion then is that 24% is within our confidence interval. At a 5% level of significance. Okay, so that's it for this question. Okay, the next question is question 8. A fish shop has a vertical sign outside its front door. In the diagram below, the sign is represented by the line segment FH with the line segment FH equal to 3 meters. So that's it here. A cable is tied at the top of the sign and is secured at a point G on the horizontal ground. G is 1.4 meters from the base of the sign H as shown in the diagram below, which is not to scale. Use the theorem of Pythagoras to find the length of the cable GF. Give your answer in meters correct to one decimal place. So we've got to use Pythagoras' theorem. So that's just going to be 1.4 squared plus 3 squared equals the length FG, which we've got to square. So 1.4 squared is 1.96, 3 squared is 9, and that's equal to FG squared. FG squared is equal to 10.96. And what we've got to do then is just square root both sides. So the distance from F to G is just the square root of 10.96, and we've got to do this to one decimal place, so it is 3.3 meters. Okay, so let's look at part 2. Show that the size of the angle FGH is 65 degrees to the nearest degree. So FGH is this angle here. So what we're going to do is we're going to call this the angle FGH, and we're going to get the tan of that angle, which is opposite over adjacent, which is 3 over 1.4. So let's do that. So the tan of the angle FGH is equal to 3 over 1.4. So that just means that the angle FGH is equal to tan inverse 3 over 1.4. So that means finally then that our angle FGH is equal to the nearest degree is 65 degrees. The nearest degree. Okay. Next one then. A second cable from G is tied to the sign at the point K, where K is halfway up the sign FH. And they show that here. There's FH, which was 3 meters, and K is where the new cable is tied. Murade says that the size of the new angle KGH is half the size of the angle FGH. Is Murade correct? Use calculations to support your work. So we've got to calculate this angle here now and see is it half of what we got before. So let's do that. So it's the same kind of thing again. We're going to say the tan of the angle KGH is equal to, this time it's going to be half, it says it's halfway up, so it's going to be half of 3, which is 1.5 over 1.4. So it is 1.5 over 1.4, so that just means then that the angle KGH is equal to tan inverse 1.5 over 1.4. So the size of the angle KGH is going to be equal to 46.97 degrees and so on, which is not equal to half the angle FGH. So the answer here is that Mairead is incorrect. Okay, so now we have the fish shop has a logo with some measurements as shown in the diagram below, not to scale. AB is 12, AC is 10, the angle ABC is 37. Work out the size of the angle theta, where theta is the angle BCA. Give your answer correct to the nearest degree. So we're looking for BCA, we're looking for this angle here. So we're going to look at this triangle here. We have two sides, we have an angle opposite one of the sides. It's not an enclosed angle, it's opposite to the 10 centimeters. So what we're going to do here is use the sine rule. We're going to say sine of 37 over 10 is equal to sine theta over 12. Or we can just say sine theta over 12 is equal to sine 37 over 10. Now here we've got a fraction equal to a fraction, so you can cross multiply. So we're going to say 10 sine theta is equal to 12 sine 37 degrees. That just gets rid of the fractions. We want to find theta, so I've got to get sine theta on its own. So that's 12 sine 37 degrees divided by 10. Now when you do that, 12 sine 37 is over 10. When you do that on your calculator, you get 0.7221780278. So all we've got to do now, remember this is sine theta, so to find theta then we just do sine inverse of 0.7221780278. When you do that on your calculator, you get theta is equal to the nearest degree again is going to be 46 degrees. And that's to the nearest. That's just to the nearest degree. Okay, so let's move on to part 2. CF is equal to 22, EF is 11.8, and the angle EFC is 110. Use the cosine rule to find the distance CE. Give your answer correct to one decimal place. So we've got to find the distance CE. So we've got to find the distance from here to here. This time we have two sides and an enclosed angle. When you see that, you can use the cosine rule. So we're going to say this side squared is equal to this side squared plus this side squared minus twice this times this cos this here, 110. So let's write all that out. So the side CE squared is equal to 22 squared plus 11.8 squared minus twice 22 times 11.8, and then it's cosine of 110 degrees. So you just got to work all this out on the right hand side. So CE squared is equal to 623.24. That's these two here done. Now I'm just going to do these three here. Going to multiply those three out, and that'll give me 519.2. If you get the cosine of 110, that'll give you minus 0.342021433. And let's see, if we do all of this, you get CE squared is equal to 800.8168584. Okay, so we've got to find CE then. So this finally gives us CE is equal to the square root. You've got to square root both sides. We've got to do this to one decimal place. So it's going to be 28.3 centimeters. And this is to one decimal place. Okay, so that was part 2. Let's have a go at part 3. CDEF is symmetrical about CE. Work out the total area of CDEF. Give your answer correct to the nearest square centimetre. So CDEF is symmetrical around CE. So what we've got to do here is find the area of one triangle and just double it. So what we're going to do here, again, we have two sides and an enclosed angle. So the other thing you can do with that is find the area of a triangle. So it's going to be half of 22 multiplied by 11.8 sine 110 degrees. So the area then of CDEF is going to be twice half AB sine C. So it's going to be half A, which was 22, B, which is 11.8, and then we've got sine of 110 degrees. So that's what we've got to do. So twice a half, if we just do this bit here, is just 1. So really all you got to do is multiply out those three things there. When you do all of that, correct to the nearest square centimetres, which is what we have to do, you get 244 square centimetres. And that's it for this question. Okay, so let's have a look at question 9. Dermot owns an ice cream van. Dermot sells 7 different flavours of ice cream, 4 different toppings, 2 containers, a choice of cone or a tub. How many different choices are available if you must choose only one flavour, 1 topping and 1 container? So this is the fundamental principle of counting, so it's just simply going to be 7 times 4 times 2, which is 56 choices. Dermot wants to maximize the number of choices available to his customers. He can only add either an extra flavour or an extra topping. Should he add an extra flavour or an extra topping, use calculations to support your answer. Okay, so if he uses an extra flavour, that means he will have 8 flavours. So it would be 8 by 4 by 2. So if he adds an extra flavour, it would be 8 times 4 times 2. If you do that, you get 64. If he adds an extra topping, so the extra topping, let's see, there were 4 toppings, so it would be 5 here, so it would be 7 by 5 by 2. So this is just 7 times 5 times 2, which is 70. So to maximize the number of choices, then he would need to add an extra topping. One day Dermot recorded the ice cream choices of the first 100 customers. Vanilla flavour was bought by 42 customers, a cone was bought by 37 customers, 45 customers bought neither vanilla nor cone. The information is shown in the Venn diagram below. Complete the Venn diagram below to show the number of customers in each region. So they've started it here for us. So what we're going to do first of all is, we know that there were 100 customers in total, use 100, and there are 45 outside here. So we want to see how many are inside this these two sets here. So it's going to be 100 minus 45, which is 55. So we can see that the Venn diagram is made up of 42 and 37. So if you take 42 and add 37, you get 79. So we know that there are only 55 in there, so the overlap must be the difference between these two numbers. So if we take 79, subtract 55, that'll give us 24, and this is the intersection then. So 24 should go in here. Now we know that this circle here just contains 42, so we take 42 minus 24, which is 18. So we know that 18 should go there. We know that there are 37 in this circle here, so we take 37 minus 24, that'll leave us with 13 here. So that's it for that part. Next part, a customer is picked at random from the first 100 customers. Find the probability that this customer bought a cone with a flavour other than vanilla. These are the customers who bought vanilla here. So the customers who didn't buy vanilla, going to be 13. So it's going to be 13 out of 100. So the probability of a customer does not buy vanilla, so V complement if you like, is going to be 13 over 100, or 0.13. In general, sales of ice cream increases as weather conditions improve. Dermot's typical ice cream sales for different weather conditions are shown in the table below. The table also shows the probability of each weather condition next Sunday. So let's see, use the information in the table to work out the expected value of Dermot's ice cream sales next Sunday. So the expected value, E of x, is the probability, so in the first case 0.3, which represents 30%, multiplied by the typical ice cream sales for a wet day. So it's 0.3 multiplied by the typical ice cream sales for a wet day, which is €150. Plus, the second one is 0.45 or 45% multiplied by the typical ice cream sales for a dry and cold day, which is €200. Plus 0.25, which is the probability, multiplied by the typical ice cream sales for a dry and warm day, which is €450. So again, that's all just calculator work, and we have to give our answer to, let's see, use the information, find the expected value. Oh yeah, so it just works out as €247.50. Next one, Dermot has a logo of an ice cream cone on the side of his van. The logo is made up of a sector of a circle with a radius of 20 centimeters and two identical right-angle triangles as shown in the diagram, not the scale. The arc of the sector is labelled S. The size of some of the angles are shown. So this is our diagram here. Find the size of the angle theta and hence find the length of the arc S. Give the length in centimeters, correct to one decimal place. So we've got to find this angle here, the angle from here to here. So what we're going to do is look at the fact that the entire circle is 360 degrees. We're going to subtract this 70, we're going to subtract this 70, and that'll give us theta. So theta then is going to be equal to 360 degrees minus 70 degrees minus another 70 degrees. When you do that, you get 220 degrees. Now it says hence then find the length of the arc S. So we've got to find the distance from here to here. So we're going to look at the formula for the entire circumference of a circle. So imagine that this is an entire circle all the way around. The length of the entire circle is 2 pi r. We don't want the entire length, we only want a fraction of that circle, of that circumference. So the fraction that we're going to use is theta over 360. Or we know what theta is now, it's going to be 220 over 360. So we're going to look at the length of the arc, they call it S. It's going to be 2 pi r, which will give us the entire circle. We don't want the entire circle, we want a fraction of the entire circumference. That's 220 over 360 degrees. So that's the fraction of the entire circle that we're looking for. So let's do that. It's 2 times pi, so it's 2 times pi times the radius. The radius here is 20 centimeters. That's the radius of our circle there. So we multiply it by 20, and then we multiply that by 220 over 360 degrees. So when you do all of that, it's just calculator work, you get 76.7944, 76.7944, and so on. So our theta is 220 degrees, that's fine. It says give the length of the arc, correct to one decimal place. So the length of the arc is going to be 76.8 centimeters. That's just to one decimal place. Use trigonometry to work out the length of the side labelled L. Give your answer correct to the nearest centimetre. So the side L here is what we got to work out. So this thing here, happily enough, is a right angle triangle, so we can use trigonometry to work that out. I'll just redraw that triangle. So it'll look something like this. It's in a different orientation. Oops. So we've got a right angle here, and we've got to work out this side here, which is L here. We know this is 20 centimeters here, and what else are we given? We're given opposite L, we have the angle 70. So we know that this is 70 degrees here. So it says use trigonometry. So what we have is the opposite and we have the adjacent. So we're going to use tan. So we're going to say the tan of 70 degrees is L over 20. The tan of 70 degrees is L over 20. Multiply across by 20, so you get 20 tan 70 is equal to L. So you just do that on your calculator. Again, make sure it's in the correct mode. 20 tan 70 is 55 centimeters, and that's to the nearest centimeter. That's it for this question. Next question then is question 10. In Wimbledon Tennis Tournament 2023, the fastest women's serve was by Aryna Sabalenka at 121 miles per hour. Use the conversion rate of 1 mile is equal to 1.61 kilometers to convert 121 miles to kilometers. So we want our answer to be in kilometers, so we put kilometers on the right hand side. So it's going to be 1 mile is equal to 1.61 kilometers. We want 121 miles. So how did we go from 1 up to 121? You just multiply by 121. So you do the same to the other side. You multiply by 121. If you do that, you get 194.81 kilometers. Convert 1 hour to seconds. Well, 1 hour is equal to 60 minutes, and then there are 60 seconds in each minute, so you've got to multiply 60 by 60 to give 3600 seconds. Use your answers to part A1 and A2 to convert 121 miles per hour to meters per second. Give your answer correct to 2 decimal places. So we started with 121 miles per hour. That's equal to 121 miles is 194.81 kilometers per hour. Now we've got to convert kilometers to meters, so there are 1,000 meters in a kilometer, so we've got to multiply by 1,000, so it's 194,810 meters per hour. So all I've done at this stage is converted the miles to kilometers to meters, the top part of this fraction here. So now I'm going to convert the hours to seconds. So we know that there are 3,600 seconds in an hour. So if I do 194,810 meters in 1 hour, I'm going to do a lot less meters in 1 second. So I'm going to divide 194,810 by 3,600. When you do that, you get 54.11 meters per second. So I just divided this by 3600. That's all I've done there. Okay, so let's move on to part B. Tennis balls are in the shape of a sphere. For professional tennis matches, tennis balls can be of slightly different sizes. The smallest size allowed has a radius of 3.27 centimeters. Find the surface area of this tennis ball. Give your answer in square centimeters correct to 2 decimal places. So there's a formula for surface area. Again, it's in your table. So surface area is 4 pi r squared. So it's 4 times pi times the radius in this case is 3.27, which we've got the square. Multiply all that out and you get 134.37 square centimeters. Okay, so part C, the cross section of a tennis ball is shown in the diagram on the right. The ball is made up of an airfill center and a rubber layer of uniform thickness. The external radius is 3.4, the internal radius is 3.1. Find the volume of the rubber layer. Give your answer correct to 2 decimal places. So what I'm going to do in this case is I'm going to use R1, which is 3.4, to find the volume of the entire sphere, including the bit in the middle. I'm going to use R2 then to find the volume of the white bit, and I'm going to subtract the 2 volumes. That'll give me the volume of the rubber. So let's do that. The volume of rubber is going to be the difference between the 2 sphere volumes. Now the volume of a sphere is 4 over 3 pi r cubed. So it's 4 over 3 pi or 1 cubed minus 4 over 3 pi or 2 cubed. So it's going to be 4 over 3 times pi times 3.4 cubed minus 4 over 3 times pi times 3.1 cubed. So again, that's just all calculator work. You can do that on your calculators. We need our answer correct at 2 decimal places. So the answer is 39.85 and its volume, so it's centimeters cubed. So in part D, the diagram on the right shows the smallest closed cylindrical container that contains 3 identical tennis balls arranged one directly on top of the other. The radius of each tennis ball is 3.4 centimeters. The height of the cylinder is h. Show that h is equal to 20.4. So we know that the radius of each tennis ball is 3.4. So the distance from the center here down to here is 3.4. So how many of those distances are there? There are 1, 2, 3, 4, 5, 6. To make up the height, there are 6 of these radii. So it's 3.4 multiplied by 6 and we get 20.4, and this is a distance, so it's just centimeters, so that's equal to, that's our h. So h is 20.4. Hence calculate the volume of the cylinder, give your answer correct to the nearest whole number. So the volume of a cylinder is pi r squared h. So it's pi times r, we know, is 3.4. That's the distance from here to here, so that would be the radius of our cylinder. We've got to square that, and we've got to multiply it by 20.4. So when you do that, you get 741 and its volume, so it's centimeters cubed. The 3 tennis balls could also be arranged one directly on top of the other inside a closed rectangular box as shown. Find the surface area of the smallest such rectangular box in centimeters. So the surface area of a cuboid is really what we want. Well, we know that the distance from here to here is 3.4 centimeters. So the distance from here to here, all the way across here then, is going to be double that. So that's going to be 6.8. So the length here is 6.8. So it's just 3.4 times 2, which is 6.8 centimeters. Now it's going to be a square on the top, so it's also going to be 6.8 along this way as well. So it's 6.8 this way, it's 6.8 that way. All we need now is the height along here. So we know that the height is 20.4. We've already calculated that. That's just 6 times 3.4. So the height is 20.4 centimeters. So we have our length, our width, our height. So what we need to work out is the surface area. So the surface area is 20.4 multiplied by 6.8. And what I've got to do with that is, if you look at the cuboid that we've got here, we've got, let's say, this face at the front here. That's 20.4 multiplied by 6.8, which will give me the area of this face here. But there are 4 of those faces. There's one here, one at the back, one at this side, and one on this side here. So I'm going to multiply that by 4. Now we've also got to find the area of the square at the top and multiply that by 2, because there's one on the top and one on the bottom. That'll give us all the faces then. So that's 6.8 times 6.8, which will give us the area of the top square. We've got to multiply that by 2. So if we do that, we have to find the surface area of the smallest such rectangular box. So it works out at 647.36, and this is area now, so it's centimeters squared. Okay, so that's it for this question and the ordinary level paper 2.